So we've looked at ways to solve a quadratic by factoring, solve by square root, solve by graphing, but those techniques do not work all the time. So the technique that works every time to solve a quadratic is the quadratic formula. So the quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And we spend a long time on this in Algebra 1. So example 1, solve using exact solutions. That means we're not going to have decimals in our calculator or irrational numbers. So the first one is you want to get one side equal to 0. So it's going to be 3x squared minus x minus 4 equals 0. Because this helps us determine what our a, b, and c are. So a is 3, b is -1, and c is -4. So I'm going to do opposite b. So it's 1 plus or minus the square root of b squared. So -1 squared is a positive 1 minus 4 times 3 times -4 all over, because that's 4ac, all over 2 times 3. So the steps I do is I always do that b squared first. Then after that, I take all of this and I put it in my calculator. So I do 1 minus 4 times 3 times -4, and you get 49. So this is 1 plus or minus the square root of 49 over 6. Then I try to break down or simplify this root. Well, the square root of 49 is actually 7. So it's 1 plus or minus 7 over 6. So that plus or minus means that one solution is 1 plus 7 over 6. And the other solution is 1 minus 7 over 6. So the first solution is going to be 8/6, which is 4/3. So that's an exact solution. And the other one is going to be -6 over 6, which is -1. Okay, problem 2, you're going to get one side equal to 0. So it actually doesn't matter if you add 2x squared or if you subtract everything else. Your final answer is going to be the same, because in a parabola, you can have a parabola that opens up, and it can have the same exact solution as a parabola that opens down. Oops, I didn't draw that very well, but they'll have the same x-intercepts, because that's what you're trying to find when you're solving. You're trying to find the x-intercepts. And then sometimes, when a quadratic doesn't have x-intercepts, that's when you have imaginary solutions, which we'll get to here. So in that case, if I added 2x squared to the other side, a would be 2, b would be 4, and c would be 3. So I'm going to do -b plus or minus the square root of b squared, which is 16, minus 4 times 2 times 3, all over 2a, which is 4. So again, in this step, I do this step, which is going to be -4 plus or minus the square root of 16 minus 24. So 16 minus 24 is -8 over 4. So normally in Algebra 1, we would stop and write no real solutions because you had a square root of a negative number. But we can actually break this down. So in last section, we broke this down into square root I, or I root 8, which is 2 root 2i. So this is going to be -4 plus or minus, and I'll put the I out front. So I 2 root 2 over 4. So you can actually go further with this because you can reduce all three of these terms by 2. So this is going to be -2 plus or minus I root 2 over 2. So I divide each of those green terms by 2. So you can only do that if all three of them can be divided by the same number. Okay, third one, I'm going to get one side equal to 0, so I'm just going to subtract 4x squared. So your a is going to be -4, your b is going to be 8, and your c is going to be -3. So it's going to be -b, so -8, plus or minus the square root of b squared, which is 64, minus 4 times a times -3, all over -8. So I'm going to calculate this. So 64 minus 4 times negative 4 times negative 3 is 16. So this is negative 8 plus or minus the square root of 16 over negative 8. So the square root of 16 is 4. So I'm going to have two solutions, negative 8 plus 4 divided by 8 and negative 8 minus 4 divided by negative 8. So it's negative 8 plus 4 divided by negative 8. So that's 1/2 or 0.5. And then negative 8 minus 4 entered divided by negative 8. So that's 1.5. So again, you can check. I encourage you to plug in a half into the left and right hand side and see if they're equal, and then plug in 1.5. Check your answers. Okay, then letter A, I'm going to subtract 7u squared, or the number 4, I'm going to subtract 7u squared. So A is negative 7, B is negative 6, and C is negative 2. So it's negative B, so it's 6 plus or minus the square root of B squared, which is 36 minus 4 times A times C all over negative 14. So I'm going to do this 36 minus 4 times negative 7 times negative 2 is negative 20. So it's going to be 6 plus or minus the square root of negative 20 over negative 14. So again, previously in Algebra 1, we would just stop and write no real solutions because we had the square root of a negative number. But we can break down the square root of 20. So this is going to be the square root of negative 20 is the square root of 20i. And then root 20 breaks down into 2 root 5i. Because 20 is 2 times 2 times 5. So now I have 6 plus or minus 2 root 5i all over negative 14. So I'm going to circle these three numbers because I can divide all three of them by 2. So it's going to be 3 plus or minus root 5i over negative 7. Alright, so example 2. A scoop releases a field hockey ball with an upward velocity of 34 feet per second. The function h equals negative 16t squared plus 34t models the height in feet after t seconds. When does the ball hit the ground? So when is guessing for the time. Does the ball hit the ground? So hitting the ground means that the height is 0. So we have to solve 0 equals negative 16t squared plus 34t. So again, a quadratic formula works every time, but I'm actually going to solve this one by factoring. I feel like that would be easier. So I'm going to factor out, I can divide both of these by 2 and a t. So I can take out a 2t and I'll get negative 8t plus 17. So using the zero product property, t is 0 if you set 2t equal to 0, and I'm going to set this equal to 0. So 8t plus 17 equals 0. 8t equals negative 17. Or negative 8t equals 17. So t equals negative 17 divided by negative 8 is 2.125 seconds. So 2.125 seconds. 2.125 seconds. So again, you could actually use the quadratic formula. I just looked at it and thought that I could factor it because it has a greatest common factor. And then when will the ball reach 20 feet? So what time will the height would be 20? So in this case, I'm not going to solve by factoring using the zero product property because I don't have it set equal to 0. So I'm going to subtract 20 from each side. and do the quadratic formula. So it's going to be negative b, so negative 34 plus or minus the square root of b squared. So 34 squared is 1156 minus 4 times a times c, all over 2a. So I'm going to put this in my calculator. So 1156 minus 4 times negative 16 times negative 20. And I get negative 124. So negative 32, or negative 34, plus or minus the square root of negative 124 over negative 32. Okay, so in this time we're actually talking about a real life situation here. So if I have a square root of a negative, I cannot do that. That means it's not, the ball is not going to reach 20 feet high, so no solution. So what's happening is you have this field hockey ball. It's going up in the air, and here's 20 feet. So, or 20 feet. So it's not even getting up to 20 feet. So that's why there's no solution. The second part, I'll just do a couple of these, is the discriminant. So the discriminant is what's underneath the square root, and we've kind of been talking about that. So that last hockey problem, the discriminant was negative, so there was not any real solutions, but there's two imaginary solutions. So imaginary solutions would be where it doesn't cross the x-axis. You'll have i's. When you're taking the square root of negative numbers, you'll have i's. They'll be imaginary. There's no x-intercept. If the discriminant is 0, there's going to be one solution, one x-intercept. If the discriminant b squared minus 4ac is positive, there's going to be two x-intercepts and two real solutions. So I'll do a couple of these. So the first one, I'm going to write what a, b, and c are. And the discriminant, I'm going to do b squared minus 4ac. So 6 squared minus 4 times 1 times 9 is 36. Oops, 36 minus 36. So it's going to be 0. So the discriminant is 0. So the type of solutions, there's going to be real, and there's going to be one real solution. So of the type, if the number is 0 or positive, there's going to be real. And if it's negative, it's going to be imaginary for the type. Okay, we'll do this one. So a is 1, b is 6, c is 10. So it's going to be b squared, 36 minus 4 times 1 times 10. So the discriminant is negative 4. So the type of solutions is going to be imaginary because the number is negative, and there's going to be two imaginary solutions. Okay, time for one more here. So a is 5, b is negative 1, 2, c is 4. So b squared is 4 minus 4 times 5 times 4. So 4 minus, that's going to be 80, so it's negative 76. So the discriminant is negative 76, so that's imaginary, and there's two imaginary solutions.